Hey guys, Kajimi92 here. I just figured I'd release a video on generic game programming stuff that I've learned over the years on my own of how certain kind of the architecture of a game engine might look like. I'm gonna start from scratch here. I'm just gonna do some basic concepts here, so I'm not gonna go too in depth all the way down to something that's very visually exploding. Okay. So yeah, I'm just gonna finish off braiding my hair here. Almost done. We're gonna just do a basic Windows console application, nothing crazy. In fact, we might actually, I was thinking maybe I can make this, try to focus in the direction of a text adventure game. No promises there, but I guess we can call this game engine. All good. Now, I am not too familiar with Microsoft Visual Studio. I usually use code blocks, but I just recently got a new computer, and I am, of course, open to learning new things, and so I'm going to try using Visual Studio here, because I need to learn, because I'm trying to do some NVIDIA CUDA stuff too. I might do videos on that, but who knows, we'll see. I've been reading the CUDA API, and it is very interesting and cool. Honestly, a good tip for everyone is before I start is if you really need to know something about an API, how to do something, go to their documentation first and read their documentation before you go on to Stack Overflow and ask, oh, how do I draw something onto the screen using STL? How do I make a texture appear on the screen? Just go to the STL documentation. They'll have examples. If they don't, then you can go to Stack Overflow. How I learned how to program was it was QBasic, and I learned through the F1 key. I'd press F1 over a word. I don't even know if it works anymore. F1 over include. Yeah, oh look, cool, it does. And it brings up what include does. That's how I learned how to program. And I would suggest a lot of people to learn an older programming language like maybe QBasic that way, or try to learn it that way, right? If you know a programming language already, try moving to something like QBasic or something on an older system where all you have is the man pages and the F1 key or something to figure stuff out. It truly is an experience, and I honestly would not give that my learning experience in the past up for any other learning experience. Not because I can say that there is any way to do it, but anyways, I have totally digressed from the video topic here. I keep it in French, gotta change that. We're going to include some strings. Okay, so to make sure everything works, I'm just going to go ahead and print hello world right away. Control F7, is that compile and run? We'll see. Nope, that's just compile. F7, compile and run. Nope. 5. F5 did something. Alt PP for project. And we're going to go ahead and change something in here. Try to be careful not to have anything pop up that's personal information in here. I'm using version 141. Oh wait, no, never mind, ignore that. I was using this version for CUDA because for some reason this version does not work as of a couple weeks ago. What was I doing again? linker. There's just so much stuff here. There's a way to make the window stay. I might just be doing it wrong. Just 64. In fact, I'm gonna actually look that up right now. Windows System Visual Studio console. I'm gonna do a noob search here. How to keep console window open C++. It's like I've been here before. Control F5. Right here, that's what I was looking for. Solution, right click on the, okay, properties. Linker system. PP. Oh, it should work. Control F5. Yeah. Oh, well, there we go. See, it works. Okay, so what we want to do is kind of give some ideas of a basic kind of setup of a game. Not of the whole game engine, more of a hierarchy of things. So I'm going to start off by creating a class called the game object. And this class will have components to it. We'll call it object component, and these components are they're the thing that make up the object, kind of like the properties of an object itself in real life. Like an object in real life can have a physical nature to it. It can have a shape, right? So like a mesh, or it can have a weight to it. It can have a position in space, right? So pretty much the components are a description pretty much of what the object is. And to have actual components, we have to actually have a class object component, and this will just be a generic class. Should probably be a structure actually. We'll keep it like that for now. And we want ourselves enum on type, and call object component type. and we want our types of what the object is. Since there's no graphics involved with this right now, there isn't really any dimensionality to some sort of space, or anything at all. There's no the object components really depend on the world you're trying to create in your game, right? So if you have a text adventure game, there's no space to deal with. You don't have to deal with, oh, it's at these coordinates, x equals 5, y equals 5, or whatever, right? So you really have to think about these things first before you dive into what you're making. Right now I'm trying to do a generalized view of a hierarchy here. So first we're going to try just kind of keep it from the text side. We're going to say that our objects are, let's see here, we're going to say our objects can have text descriptions of what they are. So I'm going to try popping my knuckle here, it's bothering me. It's not really working. That's fine enough. So our objects, let's see, object component type description. No, I spelled that right. And then at the end here we can add num component. The reason why we do this num components is because now for this array it's initialized to how many different type of object components we have. We have one component, and so this is actually the value of 1 because it goes 0, 1 if we don't specify the values. And then so this is 1, so we have an array of a size 1 for the object components. Down here we want to have our object component type like that. We're going to have a public this is just, you know, C++ stuff for objects here. We're just adding this in here too. Oh my goodness. Apparently I can't type today. Naturally you'd want all these to be in their own header files, but I'm just doing it in one right now for demonstration. I don't want to bother with making new files right now. So object component type right? We don't want that. Type is type. That's all we want right now. There we go. So now we have our constructor for object component, which is default object component type. Type sets this to type, and we don't really need anything else in there right now. The reason why we do this is because now we can create objects based off of this, right? So we can create our description object component. So we can have our class descript. You can call it description component or object component. It might be best to use the same name there. Component, right? And it is of public type object component. It's going to inherit our object component class. Reason being is now, let's say for public, oh what the heck, home tab, there we go, public description object oops, see, I'm still getting used to the typing. In code blocks you can type a little bit then press enter and it would finish it, but this one you have to type something, press the down key or the arrow keys to select which one and then press enter. Code blocks you could just do the arrow, press the arrow keys to select which one, but it was automatically selected on the one that was highlighted first. Yeah, so right now we have this. Right now we do right away we call the object component constructor because that's what we have to call first, and we pass it the type object component type description. We're going to go ahead and put a string in here. Description. String. Description. And then we're going to have the other one here. Description. There we go. Or yeah, to keep it nice and oops, we'll put that down too. There we go. So now we have a whole description object component that when we initialize it takes in one of these, passes it in, right? So we can have our description object component disk. There we go. And then we pass it hello world. Right, so we can have our description object component initialized like this. Calls this, right, initializes the object component because it inherits that. So yeah, so type is then set as description, and then we have set the description of the object. So yeah, right now we only have this object component with one of the components here, so we don't have any way of actually doing anything with this, right? All of this functionality, there's no functionality here, it's just classes that we're working with right now. So what we can do is in the object class we can have we can add our constructor. We don't really need any sort of thing right now for that, since all of our data right now is all pretty much, there's no data that we need to manage ourselves right now, which is good. And if we really want, we can try to keep it that way, because then we don't have to worry about pointers and stuff. We do have these pointers to worry about, and these are the important pointers pretty much that we should be worried about. So object, actually we don't even need that right now. But what we do need is our public functions for adding components to our game objects here. Oh, we need this. We need to add a function up here, actually. 1 second. We want to add to our object component a way of retrieving the component type. This is needed for our object, game object down here. Get type. All it does is return type. That's it. Very simple. And down here we want to have in our game object add component T, and we go T type T component. Oh wait, no, we don't do that. Add component game object. I'm almost forgetting what it's called. Object component. Component. Like that. Now, this function here is pretty simple. We add a component. We don't care what type of component it is because we can get it from using this function right here, get type. So what we do is we go our component we won't rename it. We'll go this component. Now this points to our array in our current game object class. We'll go ahead and go component, which points to the parameter to this function right here, and we're going to go dot get type. Equals component. Oh, there we go. The address to that component. We want to pass the address in. Or reference to, and then we want to dereference that. A safe way to do it would be you would just pass the component in and then copy it into the component array. That'd be one way, a safe way of doing it. But if we do it this way, we can change the component itself using the original component. And that way, for things like in an actual game with dimensionality to it, like a 2D game, 3D game, you can have this object that you can actually manipulate, and it will affect all these other objects too. The only downside is that you have to manage as the programmer the pointer and make sure that it's the objects that you're passing to don't go out of scope before the actual game object goes out of scope. But usually that doesn't happen because your game objects will be a part of some sort of game state, and when that game state ends, all the components of the objects and the objects themselves will go out of scope. You can also add it so that the game object manages the pointers themselves. You can have a whole nother array here that keeps tracks of if the component pointer is owned by the game object class, and if it does, and the game object class goes out of scope, it checks which ones it owns and deletes those ones itself. You can do that too. You can do that too. So we have our add component class, which we can add our component to. And right now, this is pretty much enough to kind of get a basic idea of the structure of kind of game objects and what they can do here. We're going to go down. We just need one more thing here, a way to access the components of a game object. So get component. I'm going to use a template class here. Because what we're going to do, we're going to go T, or not even, we're going to go return oh, just had to burp there, excuse me. We can go ahead and return straight from our component class, or a component array, T. This is a whole new instance of T here, and get type right there. So that right there returns the component of this array here, or this right here. I guess we have to specify that this is a template. Whoops. There we go. We'll go here just so we can access that description. A good thing you can set these as structs so you can just access these directly, which would make sense if they're components of another object. But we're just going to keep it like this for now, and return a whole new return a copy of the string instead. You can also do things like std string, set description, whatever you want to do with these actual objects here, you can do. There we go. So then down here, let's say with our game here, we have our object description object class, but we don't actually have a game object. So we're gonna go down here, game object, and we're gonna call it the hello object. We don't have, there's no specifiers for creating the object. Where is it all? There we go. We don't have our what should we call it, constructor, because there isn't really anything we need to set up initially for our object here. Actually, we're going to go ahead and actually make one anyways. Or I'm not sure how Visual Studio sets up arrays, if it initializes it all to 0 or not. I'm going to assume that it initializes arrays to 0 if it's an array like this. so we don't have to add that. But you can have the constructors for things like, let's say there's a certain object component that every single object has and has to be set. Like let's say in a game that has dimensionality, a 2D, 3D game, pretty much every single object you'll ever make or add to the world will have a transform, meaning that it'll have some sort of two-dimensional coordinates or three-dimensional coordinates, some sort of rotation scaling. It'll have that, and so you can have right in your game object class, in the constructor, parameters to create the default transform of the object. But since we don't have any sort of thing in this that guarantees or that is needed to have some sort of that every game object has in this demonstration here, we don't need it. So down here. Now, as we set it up, we can just simply add with our hello object. We can add component, and then we go our disk. We'll actually go description. Good Jello. Nah. Hello world. So there we have it. There's our whole thing here. It should compile and run. I will make sure that it does right now. One failed. Game object, game job, no matching overload function found. Just gonna try fixing all that there. Maybe that's what I was missing. We're just gonna go ahead and go game object and just do nothing with it. See what happens there. Proceeding, skipping a parent function body. Class T. I'm going to press that F1 key because that's super useful, I guess. Templates. Templates are the base for generic programming C++ as a strongly typed language. C++ requires all variables to have a specific type, either explicitly declared by the programmer or deduced by the compiler. Type name. Let's see what that would do. Undeclared identifier, that's because this is not working. Expected tokens supposed to be skipping a parent function body. It might be that's doing it. Yeah, that's what it was. Wow. Just shows how much I know, eh? Ha 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 ha. See, nothing really happens. I go Control F5. Still gonna say hello world because it's printing off this right here. We'll get rid of that. It should say nothing now. Right? Well, except for that, due to it being a console application. But we want this to appear. So what we're gonna do is actually we're gonna add something to a concept here. We're gonna say that every single the game, the world, the universe that we're trying to create has a central node to it, a kind of a parent to everything, something that everything can point to and be like, hey, this is my man, right? So this would be the root object, the root game object to any game state in the game. And so we're gonna just have it right here. We're gonna go ahead and say it's a game object. I'm gonna call it the super game object, not game object. Oh goodness. And all it does is it's supposed to be the guy, okay? But before we can actually use this object for anything, we have to have a way of saying for other objects to be like, hey, this is my guy, this is my parent, this is who I like to be affiliated with, right? So in the object, we need another array here. And actually what we're going to do is we're going to use the vector class. Right, that's just so we can grow it and shrink it. And we're going to call it game object. We're going to use pointers to those objects, and we're going to call these the children. So each object itself has children, and it knows who those children are, and they're kind of responsible for their children. Just as you'd expect anybody to be responsible for their children in actual life. So we're going to take these children, well, we're not going to take these children, but we're going to add another function here down here. We're going to have it void we can have either set parent or attached child. It's really up to you what you want to do. One of them might be harder to do than the other one. I just need to think which one's easier, which one's harder. We're going to do set parent. And we're going to do game object reference again. Game object. Now what this does is that now we have we need to set this function up so that when we call set parent, we go game object, hey game object, add me to your children's list, right? So we go game, oops, object dot children. That's a word. Children. There's no such thing as contained. Yeah, no. Then you do dot push back this like that. Right. So then we added this object to the parent object. Now you might be thinking, well, there's definitely going to be a problem with that. What if you call that twice? Well, that's a good point. You'd then be adding the object twice to it, and it might, depending on how you implement your game or something, objects might be updated twice if you're following my layout here. So to kind of fix that, you actually have to check to see if this is inside children before you add it. And I spelled children wrong. I don't know. So what we're going to do, we're going to go ahead to the vector class here. F1 again. Wonderful F1. Look up some stuff here. Because as a programmer, you should never be expected to remember everything about something. It's pretty sure it's defined. And it's probably not even in here, it's probably in algorithms. Is there just a contains one? Could it be up here if it did exist? We can use find. Locus the position of first occurrence of an element in a range that has a specified value. Find. Iterated T class find first, last, and the value. Awesome. Okay, so down here, I do this right. Find, oops. In-game object dot from the first, the very beginning of the vector, not being, beginning, to the game object dot end. You want to see if this exists, if this is there. And I'm pretty sure it returns if no element is found which with an equivalent value, returns last. If this does not equal game object dot end, then we add it, just like that. So hopefully you kind of, oh, whoop, I forgot the children. I'm spelling that wrong. So it's std find. It looks at the first iterator. It goes from the first iterator all the way to the last iterator. So it kind of checks, does this equals the first one, and then it goes this plus plus. Does this equal the next one? Does it equal the third, fourth, fifth, all the way until we get to the end, and once it gets here it kind of quits and returns. And if it didn't find it, but if it does find it, then it returns the iterator where it's located. But we don't really care about iterator of where it's located right now. We just want to know if it's in the children array, and if it is, then we add it in. Otherwise we don't add it. Something else we have to add here is the game object parent. This is important because now we also have to do this. Parent equals dereference game object, or the address of this object right there. This is so we can access our parent if we need to. And now we actually have something that we can actually use this for. Parent is no. Just like that. We want our void remove parent. We go if parent, because if we don't have a parent, we don't care, we don't do anything. But if we do have a parent, then we want to remove it, so we go parent dot children we go we'll go auto. What the heck did I just do? Auto, because I'm not quite sure what I should be typing for the iterator, what the iterator type is. We'll do auto, and we'll go iter, and the iter is going to be the iterator. Iter is going to be parent children. It's not going to be that. It's going to be std find, exactly what we did here. We use this function to find the iterator. Like that. Then we're going to go parent children dot erase iter, and this is going to remove this game object from the parent's children vector. This is not parent. There we go. So looking at the parent's children vector, finding this game object, and then erasing this game object from the parent's children vector. And we set the parent of this object equal null. So then the reason why we're doing this parent-child relationship here is for a hierarchy kind of situation. It's usually used with animation where you have a parent that has its properties like a transform, and then its child's transform, its location in space, its coordinates are dependent on its parent's coordinates. So let's say you have, let's say, let's see if I can find something in here. Like right here, this window right here. Let's say this Team Explorer window here is an object, a game object. There's stuff inside this window that actually depends on the location of this window completely. So there's this label, this little box right here. If this is moved somewhere else, you can see it follows with it, right? It goes wherever it goes. It's over here now. And it kind of goes over here. And so this is a child of this parent team object window. Right, and it depends on the properties of its parent. So that's kind of the idea there, is that this is dependent on this. And so when we call, like, let's say a draw function for this window, it'll call a draw function for this window, but it will also recursively draw the draw function for like the windows, the objects within inside the window, like this, everything, right? So that's kind of the idea about this. So what we're going to do, we're going to actually add a function called void. We're going to call it render object, even though it might not be the right term for it. Game object, and we're going to take a reference to it. It's going to be a constant reference to it. Oh my goodness, what did I do? So it's going to be a reference to a constant game object, meaning that we can't change the properties of the game object itself. I'm going to remove that because that would mean I would have to add a bunch of consts everywhere to my code, which I don't want to do now because that would require me some time, and I really want to get this video done with. So we have, right now, pretty much our rendering is pretty much just we just want to put the description out onto the screen, right? So we have our description game object component, and we know how to get the description. Use this. We can set the description too, but that's not what I want to do. So what we do is we go we can do it a variety of different ways, but oh, sorry, I had to burp again. Excuse me. We can attach the functionality of the drawing to the description object component so that it has a function in here that says, hey, when you do this, do this. It's kind of like when we call it render object, it goes to each of the components and looks for and tries to call a render function on them, and if they have a render function or something, then they'll do their rendering. That's one way of doing it, and that neatly encapsulates the functionality into the object class itself, which is good, and it's nice and neat. But right now we're just gonna kind of put it into the render object. It's going to be a little messy and not too clean. So what we can do is if game object dot, actually we can go I equals 0 I is less than object component type. I keep pressing things I'm not trying to press here. Now what we can do is we can cycle through each of the object components and do things that are related to each component. This is one way of doing it. There's other ways of kind of managing it. I'm pretty sure in my actual game engine that I've made, it's a bit different. But this will work for the this kind of text adventure kind of style thing that I'm doing right now. Even if it goes that far, right now it's mostly just a hello world program using a lot of data structures that are not really necessary at the moment. But here, let's see. So you go. Actually, before we even do it this way, we're just going to simply std strings. Simple right now. Description game object dot get description component. Now this is the cool part. We can use the template to actually specify the description component as such, right? So we have one get component function for all of the classes there. That should work. There we go. Object dot. What? Description object component. Description object component. Oh. Reference. Oh. This is why. My bad. And we want to dereference the object there. What you can do is also, if let's say there isn't an object in there, it's null, you can throw an exception. You can also add a whole nother function, template type name t void has component, and you as the programmer would be responsible for checking this first before calling the other functions. Get component. You can actually do type like that right now, probably. Keep it nice and clean. So there we can have a has component function too, which returns whether or not there exists a component. You can also, since it's a get, we should also have a remove component, but we don't need that currently. So there we go. Get component, description object component returns the description object component here as a reference, so that we can go std string description. If you don't need that, what we can do is we can go printf %s /n description. We go description component dot get description dot csstr, because we have to kind of write it for this function here. Down here we go super dot, oh no, we go hello object dot set parent super game object. Whenever we call a render object on a game object, we call it also on its children. It's up to you whether you want to call it on the object itself first, then its children, or its children and then itself. But for this right now, we're just going to call it on the children. So for auto child game object center game object dot children. You have to add this here because this is private, so we could put it public, but that's not really, you know. You want to kind of specify through your contracts while you're programming. And this, pretty much, the class description is the contract saying, hey, these are private, don't touch these. If you want to touch them, use this function here, because this function might do something that you might not know what it's actually, some special thing that it might do before it actually touches the objects. Anyways, get children, but really this is not doing anything right now. We're going to actually return a reference to it too. It's going to be a complete we really don't need these semicolons, but since I've already added them everywhere, I'm going to have them anyways. So child, get children, and then for each child we want to call render object on it also, like so. We also want to dereference this because it's a pointer, and the object render object class accepts non-pointers. They accept references. So there we go. So we can go down here, hello object.add component description, hello object set parent, and we can go and call render object super game object. Right, and this, hopefully, it should. Let's compile it first. Something's not right. Type. error left of dot t. Like it must have struct class struct t again. Left of doesn't care about it right here. That's kind of weird. No constructor could take the source type or constructor overload resolution. Oh, that's right. For each one of these, we also have to make a base. One that accepts no parameters, because we're calling t with no parameters down here, and we have to be able to do that so that we can set up our type so that we can pass our type as such this way. Like such. No guarantee that this will work. There we go. F7. So now return cannot convert object component to description object component reference. Dereference. Yeah. Oh. Reference, eh? I know I did this. It works somehow. There we go. We want to convert this first to the pointer t. and then dereference that pointer to return it as the object type. It's kind of a little tricky thing here. Control F5 here, and it's not working. Embarrassing, that's what I say. That's why we have debug though. Right here, what's going on here? Access violation. Cool. Let me go back. We're going to stop it. We're going to go in right there. Maybe that. And we're going to step through it. Try to see where it's broken here. F-flat is step in, step over, step out, step over, step out, step over, shift F10. Oh, I want to step in right now. That was F11. You can do it this way. Obstruct at null. Description component is null. And you keep going and see what happens. It breaks right there. And go back to where we were. Description dot get description C string. This is what breaks it, because this is not working. Game object dot get description component. Get component description object component. T. Construct a version of T. Get the type of it. Dereference it. Return it. Get component should only work if it has the object. Oh, I know what's going on here. It's trying to print something that doesn't exist for this object. So what I should have really done here is if game object dot has component, thing that I did make, description component object. Then we want to do all this, because if it doesn't have that, then we shouldn't bother trying to print out any information about it. Why is it underlined? Yes, stop debugging. Well, they forgot I was in debug mode there. Failed. Expression type void cannot be converted to other types. Whoops. It's me with my void here. It's causing a bunch of issues. Yeah, it succeeded. There we go. It's doing that. It's good. It's not breaking. Man, game object.component, it should be in the first one. It should go super object, try to do stuff, right? And it goes child. What we can do is add the description object to the super game object. We'll have another description game object. Super description. We'll call this the super description. For a lack of better anything. /n. And we'll do /t2 here, so that it'll print this out, and then on the next line it should print this out indented with a tab. We just need to go with our super game object. Don't have a component. Super description. There we go. Description. Super description. The only problem is it's not printing the rest of it. It's not printing the children. So if we look at the set parent for the object, the problem might be there. So if you go to set parent, we want to find, oh, that's the problem right here. Thing is, if we don't find it in here, it'll return this. So we want to make sure that we add the children to the array if we don't find it. But if we do find it, then it won't equal, then this find function won't return this, right? So that's what we're looking for. There you go, look at that. Description, super description, description, hello world. Now if you look, again, we only called render object on the super object. And then the super object itself in the render object called it on all of its children. So that's kind of the idea about that. So in a text adventure, maybe you can do that where you have description for objects, and then inside your room you'd have your super game object for each room, and then you would call a render object or print object. Render object, it would pretty much print the main description of the room and then the description of objects that are found in the room, and then yeah, you can add other functions that accept text input, and then when you press enter, it'll perform actions or on the objects of on the super game object there. So this video has passed like an hour and 20 minutes here, and it's pretty much been all on this here. If you have any questions about this is very kind of generalized, so I hope that you can take this information and kind of use it to, I don't know, whatever you need it for, right? So description object component is just something I kind of thought up on the spot. In fact, this whole video is kind of all thought up on the spot. Um, a good exercise. But try to think about what would you do if you wanted to, instead of render objects, you wanted to update them instead. How would you update them? Try to think about that instead. I can give you a hint and say that it's very similar to this function right here. It really is. And let's say, for example, with coordinates, some sort of the dimensionality of objects, how would you update them based on the parent's coordinates? What would you do? Would you add extra parameters here? Would you have the children directly access the parent? Just questions to think about, really. So yeah, I did mention before a attached child, detached child. It's kind of the same thing, except instead of set parent, remove parent, it's instead of calling hello object dot set parent, you'd be calling super game object dot set add attached child, and then you would attach this to it. Instead of going hello object dot set parent super game object, you'd be doing this instead here. Oops. You'd be doing that instead. Now, that's one thing you can think about. Maybe another thing, how would you do this? Try to think about how would you attach the child with the sort of setup I have here, and how it would work. Another question that you guys can think about is, instead of having this render object function that does the proper rendering for the objects, looking at the objects as if it were just plain data, how would you do it where you would delegate the task of rendering to the description class itself, the description object class? How would you delegate the job of drawing to the screen, writing the text to the screen, to the description object component? I can give a hint and say that it would have something to do with, still have something to do with in here, and a new function that would be in here. So yeah, so there's game objects and how you can have components to game objects. This of course does not cover a whole game engine. It only covers a very fine spot, a very specific spot of game architecture. Other parts of game architecture include the sort of game state management, which is something completely else, where like a game state has its own super game object pretty much, right? And then game states are fairly independent from other game states, stuff like that. And how you manage the switching between game states. If you've worked with Android development, it's kind of the same idea as I'm forgetting what they're called. Android development has something very similar. It's like this kind of game state idea where it switches between these different mini instances of a program that kind of together make a whole. But anyways, if you have any questions, just message me. I'll love to answer. I know this video probably was very broad and vague, and some of you might, this really isn't the video for a lot of people to be watching, but it's a good place to start if you really want to know about game architecture, if you want to learn from what I've learned. So yeah, thanks for watching, and have a nice day. Have a nice week. Well, I'm tired, it's getting late. Thanks for watching. Have a nice week.